Okay, now we're going to look into some applications of the normal probability distribution. Here again, we're going to use the normal distribution calculator. So you go stat, calculators, and let's go to normal. When we apply the normal probability distribution, we're going to use values that we've seen before. Let's say that you work in a hospital and the mean body temperature is 98.6 with a standard deviation of 0.62. And you want to know the probability that somebody has a body temperature less than or equal to 98.6. Now, since this x value is the same as the mean, we expect it to be half the curve, and that's what we're going to get. We're going to get half of this is actually shaded. Now, in the display that we have for the normal distribution calculator, StatCrunch will select nice looking numbers here. But if you select this 6895, 99.7 ticks, that will give you the values that we would associate with our empirical rule of 1, 2, and 3 standard deviations above and 3 standard deviations below the mean. So now you can ask yourself, okay, what's the probability that somebody has a fever that's greater than 100.3? And that only happens less than 1% of the time. It's going to be 0.3% of the population. Remember that we're looking for outliers in our data for a lot of these things. 100.3 is a standard value that they use to decide if you have a fever or not, and it's time to seek medical attention. And so this is one way that they use this normal probability distribution to figure out values. We could ask, what's the probability that somebody has a temperature between, let's go with 98, let's go between, excuse me, I'll do 98 and 99. And that represents 57% population. Okay, now I'm making these numbers up. Sometimes the mean and the standard deviation for body temperatures are slightly different, but you get the idea. Here's another example that we could use. Let's say you're looking at IQ scores. Generally, IQ scores have a mean of 100 with a standard deviation of 15. And we want to know what's the probability that somebody has an IQ between 95 and 105. That represents 26%, or the probability is going to be 0.26. We can go back to the standard normal probability distribution. The standard calculator. If we want to know values just simply greater than or less than in here, we can ask what's the probability somebody has an IQ of greater than 132. And that represents 1.6% of the population. We can also use this normal probability calculator. Let's say I want to know what is the IQ for the top 99%. What IQ represents the 99th percentile of people. And you can type in that probability down here, and up it comes, and that's going to be 65. Right. The reason why I was confused is I did greater than here, and actually what we want is the top 1% of the population. There we go. So top 1% of the population, we have 1% here, 99% down here. So an IQ of 135 generally represents you're in the top 1%. Flipping this calculator around, you can get the value here as we get 134 again. So, but in the 99%, and this is where I got a little bit tripped up last time. Okay. So you can use this for all kinds of things. Let's say that the mean weight of guys is 175 pounds and the standard deviation for guys is 30 pounds. And we want to know what's the probability that somebody is greater than 205 pounds, and that's 15%. Sometimes they could use these categories to determine, okay, somebody's going to be obese, morbidly obese, overweight, underweight, and so on and so forth. These are, again, represent 1, 2, and 3 standard deviations above and below the mean. So this calculator is pretty easy to use. If you want to know, say you wanted to know what two scores represent the middle of 80% of the population. You would select between here, and just like we did with the uniform distribution calculator, it's going to split that difference right down the middle, and it's going to say 80% in the middle. You're going to have 10% up here. You're going to have 10% down here, and these are the IQ values that it represents.